got 4 water monitoring stations that they mentioned earlier. We're eventually going to, there was one in the middle of this reservoir that we had to take out for a myriad of reasons, but on-farm research complications come up and nothing ever works out just right. But we've got the equipment to put in that we're eventually going to have all of them in operation. But what we're doing is edge of field water quality monitoring, which is exactly what it sounds like. We're setting up these automated water samplers at the edge of the field, and we're collecting the water that is running off the fields. And our goal is to capture a runoff event. So if y'all are familiar with the way the hydrology of a runoff event works, it's almost a bell curve. You know, it builds up. You get your peak runoff and it tapers off. So our goal is to capture everything under that runoff event. So there's almost as much art as there is science to it, because you never know how much it's going to rain, and you're not always sure how much the farmer's going to put on the field. So we're always tweaking our flow pacing, which is how much we capture in that each event. We've gotten pretty good at it, but there's always some tweaking that needs to be done. So what we are using predominantly are these ISCO 6712 automated water samplers. ISCO's pretty much who you're going to go with if you're looking at edge of field monitoring. There's some other people on the market, but we've had great relationship with them. We've got some older samplers, Sigma samplers that we use in a few limited areas, but predominantly the ISCOs. And ISCO's got a whole variety of different types of samplers. If you want one that's refrigerated, or different bottle arrangements inside of them or whatnot. But on all of our discovery farms, we're using the ISCO 6712, and we are pull the top off of it. They're programmable automated samplers. It's a little computer in here that lets you set up when it's going to capture a sample and how large that sample is going to be. It's got a pump tube in the top that works exactly like if you've ever been in the hospital and had an IV put in you. It's exactly the same kind of pump, just a larger scale. So you've got your suction line going to whatever your source is where you're capturing that water, and it's going into the sampler. We are collecting a composite sample off of each field. Some people will go to discrete sampling. This particular model of sampler we use has got an option to take 24 1-liter samples in 24 1-liter bottles inside of it, but we are doing a composite. So we're taking a 10-liter sample from each event, and it's collecting in 10-liter carboy. So just a big 10-liter Nalgene. We're shaking up the sample and then processing it in the field or in the lab, where it's going to then be taken to whatever lab that particular farm samples are going to. We work with both the University of Arkansas's water lab in Fayetteville and then Arkansas State University's water lab in Jonesboro. We've got some farms go to different water labs depending on what that research, who we're working with on those farms. And then I don't know if you guys want to go through that. That's basically what we're turning that 10-liter sample into. So we're working on collecting a 10-liter sample, and then it's going to be divided up into a collection bottle like that. So we're taking 2 125 milliliter subsamples from that. One of those will be acid treated so that we can stop microbial activity inside the sample. That sample will be used for total nitrogen and total phosphorus. So that's what we're looking for in those samples. The other is not acid treated, and then we've got a bulk sample in case the lab needs extra. Then we're also, Brittany's got a syringe there and a syringe filter, so we're filtering a sample down to 0.45 microns through that little syringe filter, and if you've got some sediment runoff, that you'll go through some filters. It's pretty difficult. So we're taking a 40 milliliter and a 20 milliliter subsample. Those are for our ortho phosphorus, or water soluble phosphorus, what we're looking at there. And then we've recently started doing potassium as well. So we've got a subsample that we're doing the same filter treatment to look at potassium. So that all gets refrigerated and shipped to the water lab for analysis. Happy to answer any questions that you guys have.
Here's some pictures.
So when you're looking for phosphorus content, why do you want to filter the sediment out when the phosphorus stays absorbed to soil particles?
That when we're looking for both total phosphorus and water soluble phosphorus. So that's why we filter it. So we're trying to capture that water soluble phosphorus before it can have the opportunity to bind to sediments that's in that sample.
Okay.
That's right. Brittany's got some pictures here. I mean, we're basically using those, what you can see on the deck boxes like you can buy at Lowe's, Home Depot, or whatever. That's housing our equipment just to keep them safe from the elements and provide a habitat for frogs and wasps. And then here's kind of, you see the setup.
Why potassium? How did you add potassium?
Because Dr. Sharpley decided that he wanted us to look at potassium.
A fine reason.
Yep.
I thought so.
Yep. Basically, I think it boiled down to it wasn't that much more expensive, and we were almost already had enough volume in the filtered samples to go ahead and do it anyways. So by adding another 20 milliliters, there's more data we can look at. And so there's different ways we can trigger these samplers to collect the water sample. Actually, there's a ton of different ways. If you go through the ISCO catalog, you could they've got some really interesting stuff. But we basically use either a pressure transducer or an area velocity meter, depending upon what kind of area we're looking at, whether we're looking at an open channel flume, or we're looking at collecting water out of a pipe. For collecting water out of a pipe, we predominantly use an area velocity meter. That's this little guy here, and that's what we've got a picture of if y'all want to pass that around. So the area velocity meter, this is actually one here from Stuttgart. This is just a plate that it's mounted on to be mounted in a pipe. This little guy's got a pressure transducer and a little Doppler sonar sensor in it. So this will allow us to know the level, the stage height of the water, and also the velocity of the water in one compact unit, one sensor. So that we can program the ISCO sampler to collect a sample based on the predetermined height and a predetermined velocity of the water that we're collecting. That if you just got a little trickle of water, your suction line's not going to be deep enough into the water stream to actually be able to collect anything. So you've got to have a certain height of water before you can actually be able to get it. And then in some of our other farms, the Discovery Farm in Dumas, Steve Stevens' farm, it's all flumes that we put in, so open channel flow there that we're using flumes. And in the flume we use a pressure transducer. So this is much simpler and much cheaper then the area velocity meter, this is basically giving us depth of the water, the height or stage of the water, however you refer to. And since we are putting this in a flume, the flume has a pre-engineered geometry to it. So based on the height of the water that's going through the flume, we can use a formula to calculate the velocity based upon the height of the water in the flume and the known geometry of the flume. And we've actually got 3 flumes setting in the parking lot at the state extension office that are eventually going to go here on this farm. All 3 of these sites along the tailwater recovery ditch are going to be replaced by those flumes. We've been talking about doing that since the spring, but weather, planting, scheduling, we've just not been able to get that done. So we're hoping this fall, this fall, we are going to put flumes in here at the Dabbs farm to replace the area velocity meters. We have been using Wright's levee gates as a makeshift flume, and there's a lot better way to do that. So we invested in the flumes, and that's what we're going to put in. So that's probably more than any of you wanted to know about the equipment we use and what we're doing. But if anybody has any questions.
So you want to tell them about the other low-cost options?
All right, so you'll see Michelle pointed out our outhouses when we came out here. The taller buildings that you see out here, Dr. Dennis Bush out of the University of Wisconsin at Fayetteville, and some of his students and colleagues are working on a low-cost alternative to this equipment, because this is an investment. These are not what you'd call cheap equipment. By the time you've got the sampler, just the stand and the house to put it in, all of our samplers have got cellular modems on them, so we can get text information, so we don't have to actually go check them. And the sensors themselves, the flumes, spring rings, however you're attaching it, it all adds up quickly. And so to offer a more cost-effective alternative, the folks at University of Wisconsin at Fayetteville have developed their own competitor or replacement for these. So we're doing, he doesn't currently have any of his equipment in at the moment, but over the past couple of years we've been doing side-by-side comparison with what you can buy on the market right now and what they've developed at the University of Wisconsin to do a comparative analysis of what kind of data we can collect from this versus what they can collect from their samples.
How does their system differ?
Well, I've sat through that speech a couple times. I could give you some highlights from it, but that's a little out of my area. All of their stuff's built in-house. I know they work with their engineering students and their engineering faculty a lot. Michelle, do you have anything to add to that?
Yeah, so their system, the idea is that it's kind of foolproof. You have a box, you have some plugs, you can't put the plug in the wrong place. And so it should be fairly straightforward to get out. The idea, which you touched on, but I just wanted to expand on a little bit, is, across the state of Arkansas, we have, we wrote a little paper on edge of field monitoring in the state, and across the state we have a network of, at that point when the paper was written in 12, I guess, we had 25 locations on 13 farms, something along those lines. That's expanded a bit since then, but the idea is that's not a lot when you think about all of the acreage that we have in the state. And so the idea of this lower cost system is to put them at more places. We may lose some accuracy, but we'll get more data and more of a sense of what's going on. So the Dabbs are exceptional, right? And so they're at the top of their game, and that may not be representative of everyone in the state, how they're managing their land. So being able to get these out on more of a wider range of producers will get us a better picture of what's actually happening. And so to answer your question about the comparison, we're still working on the data. They've come into some issues with kind of continuing that effort, but we are working on making those comparisons. We have the same outhouses at our sites in Cotton, and we're still working out the differences. We don't expect them to be very different, and you know, they've really worked on a system that works quite nicely. They put a lot of effort into it, and we just need to kind of see how they can produce those systems and start to get them out once we get a sense of the actual numbers.
You were mentioning University of Wisconsin. I mentioned the social media advocating, and when this post came up the other day, it was a Wisconsin Discovery Farm woman and an Arkansas Discovery Farm woman that both jumped on it and said, "Oh, no, no, no." And we have data from our farm, so go look somewhere else.
We have made a effort, and our social media has grown leaps and bounds in just the last 6 months. So everybody will follow and like Arkansas Discovery Farms on Facebook and Instagram, and maybe Twitter soon.
We were talking about the dicamba issue, and so much of it, I mean, with everything today though, but it's how it's portrayed in the media and in social media and mainstream media. But it's up to us as discovery farmers and as farmers and people involved in agriculture to put out the best information that we have to refute the misconceptions and the myths that are out there. And I think that's why we're so open to people being on our farm. And yeah, you might find some. We worry about people noticing a pesticide jug. Well, we're open to that. But we want the information out there as to what we're trying to do, and that we're not necessarily the bell cow, but we hope there's more and more people following suit and opening up to gathering this information to put out there, because agriculture needs all the positive reinforcement we can get right now.